Okay, let's give you guys some practice now. So the curvature is given by this. It can also be written in this form. These two are exactly the same, but just written differently. Well, anyway, work out the curvature of this position vector at time t equals pi over 2. So when you read this vector, look at these two. So looking at these two, you know it's going to do a circle like this. The particle is going to travel around in circles, but then you've got an element of acceleration. So you know the particle is going to accelerate upwards like this. Okay, because when you differentiate this, the velocity will be 2t differentiated again. So you can see there's an element of acceleration of 2 in the z direction. Well, anyway, work out the curvature of this position vector at time equals pi over 2. So press pause and have a go. Okay, so to do this, we are going to use this formula here. So hang on. So using the formula, we need to compute the velocity and the acceleration. So looking at the position vector, differentiate it, that will then give you the velocity vector. Differentiate it again, that will then give you the acceleration. And then now we need to take the cross product of the two. So working out the cross product, it would be ijk, and then your velocity, and then your acceleration, and then, well, the cross product would be us doing this. Looking at the eye, discard. Now just looking at these four, it would be this times this, and then take away this times this, but there's a negative here, so it's going to become a positive. And then the j, so looking at the j, discard, and then just looking at these four, it would be this times this, plus this, take away this times this, but then there's a negative here, so it becomes a positive. And looking at the k, discard, just looking at these four, this times this would be this, take away this times this, that will then give you this. Don't forget it's plus, minus, plus, so this plus here is here, and then this minus here is here, and then this plus here is here. Or the cross product would be given by this. Okay, but by the way, there's a more efficient way of doing this. I'm just doing it the long way. Right at the end of the video, I will show you a quicker way. Well, anyway, the cross product would be this. The cross product would be given by this, and then let me think, so the cross product will be given by this, and then we want to evaluate it at time equals pi over 2. So at time pi over 2, we will put this into here, then this whole thing here will then become this, and then put pi over 2 into here, this whole thing here will then give you this. Put pi over 2 into here, this whole thing here will then give you this. So evaluating it at pi over 2 will then give us this. But then if you look at the formula, so we've just computed this. So all we've done is this. Now we need to take the magnitude. We need to work out the magnitude of this vector here. So the magnitude using Pythagoras, this squared, and then this squared, and then take the square root of the whole lot. So this whole thing here, this thing here would be this thing here. So we can put this into here later on. But then looking at the formula, we need to work out the magnitude of the velocity vector. So earlier, velocity vector was given by this. Remember, we started out with this, differentiate it, velocity, differentiate acceleration. Well, this is our velocity vector. We need to work out the magnitude of our velocity vector. We need to work out the magnitude of our velocity vector. So looking at velocity vector, evaluate it at pi over 2, that will then give us this. And then we need to work out its magnitude. So square this, that would be 1. This is going to be square it, 0, square this, that will then give you this, and then take the square root of the whole lot. That will then give us the magnitude. So we can put this into here. Don't forget we need to cube it later on. And then we can put this into here. So the whole lot here will then become this, and then which is approximately this. Now going back to here, we could do it more efficiently by doing this. The reason why I did it the long way is just so that I want to show you what's going on. So here, when you differentiate it, it gives you the velocity. Differentiate it, gives you the acceleration. Because you're evaluating at time equals pi over 2, put it into here straight away. So that will then give you these two vectors. Now work with these two vectors as opposed to working with this. You can just do it like this. So this is your velocity, acceleration, and then it becomes a lot easier. So looking at the I component, discard. So that would be this times this, which would be 0, and then take away this times this. You've got two negatives, that will then give you a positive pi. And then looking at the j, discard, and then it would be this times this, take away this times this. That will then give you this, and so on. The point is that because you're evaluating it t equals pi over 2, put it into here straight away. So that will then give you these two. Work with these two rather than working with this. I wanted to show you what's really going on. Okay, so well, your final answer will be given by this. Okay.